Welcome to Infrastructure Unbound by StackGen. I am Rick Walker. I'm your host, and I'm really excited to have the CTO from SymphonyAI, Raj Shukla, here with me to talk about his experiences and share some insights that he's gained over a career kind of living in the AI space before it was the AI space. So we're happy to have you here, Raj, and looking forward to the chat.
Thanks for having me here. Excited to, just brainstorm where we came from, where we're headed. Excited to be here.
Very cool. Very cool. Thank you. So one of the things that I've noticed as I was, doing my research and trying to understand, okay, but where is Raj coming from? And I've noticed you have a bit of a contrarian take on AI, if you will. And I'm curious to hear kind of what you think is possibly the biggest misconception that you see in particular with the enterprise AI space. Right, that's very different than the consumer space. So I'm curious to hear your thoughts there.
Yeah, I don't know contrarian or not, but enterprise AI is hard. And
Yeah.
it's uh, the chances of failure and all the points of failure are just way bigger than consumer AI.
Hmm.
So if you imagine there's a hype cycle in consumer AI, that hype cycle just, grows many multiples more in enterprise AI, not for any fault of the models or the foundation models or LLMs or anything like that, just out of, all the different touch points, connectors, data sources, action APIs, everything that
Hmm.
has to go right for an end-to-end AI system to work. So uh, I think uh, there is a reason enterprise AI kind of lags consumer AI, but if you think of the hype cycle, and if a CEO or a CXO of an enterprise goes into that hype cycle, and from there to
Hmm.
see the outcomes, it could be it could be a challenge to see that through. You go into it
Sure.
imagining it would just show up, but it'll take a lot of work to get it right.
Yes. Yeah. No, definitely appreciate that perspective. So I guess kind of dialing back a little bit from AI in particular, but there's a pretty widely dispersed statistic that roughly 80% of engineering initiatives fail. Right. And there's a variety of reasons, but I'm kind of curious, like how you think of engineering initiatives and maybe some of the tenets or metrics that you might look for to ensure that what you do spend your time on is being worthwhile for the organization.
Yeah, I mean, as far as uh, kind of the software development life cycle, and um, if you look at that angle of engineering, uh, a lot of initiatives there are you. I think first of all, just take a step back. I think there is no
Mhm.
doubt that the LLMs and foundation models are very transformative. It is,
Mhm.
I think, uh, I think to a certain extent, just from the fact that these models are so good at writing code, and
Mhm.
writing code is the kind of foundation of everything software, whether it's writing software or deploying software or monitoring software and all that. Uh, in some sense, uh, you could say that the hype is, it's underhyped in some sense because the models have become so good at writing code. I think what needs to be built around is, I mean, what's started to be referred as context engineering now, but
Mhm.
it's all the uh, uh, you know uh, 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 any engineering life cycle or any software development life cycle is not a straight path, right? It is multiple people writing code, the code being
Mhm.
merged, that code going into deployment. There's multiple users using it. Each user faces a different problem or error. Some users report it. Some of that reporting
Mhm.
gets logged. Some of it doesn't get logged. Then there is someone else debugging it
Yeah.
and solving it and so on. So if you think of this as a very large enterprise process, and you think of all the metrics I can use to measure, effectively how this goes, the complexity lies in realizing that, kind of data and feedback is getting generated as each step of this process. And
Hmm.
unless you capture that and unless you put that into context, you will never really solve the whole problem. So engineering
Sure.
metric wise, when we start at the beginning, you look at kind of all the developer productivity metrics around lines of code, percentage of accept rates, how
Hmm.
much actual code is being written by AI that goes into sprint velocities, PR merge time, all of those granular metrics that go into it.
Yeah.
And from there, kind of all the way, once you go into the merge, once you go into automated testing and deployment, it then goes into kind of life site metrics like uptime and mean time to resolution and all of that from that
Sure.
life cycle. And then I think the part that often gets ignored is that uh, uh, the the feedback loop that comes back, there is no
Hmm.
good metric around how long it took for that feedback to be kind of taken and some code needs to be written for that feedback, for that thing to be
Sure.
fixed. And so while mean time to resolution captures that immediate bug fix, kind of the end to end, what code was rewritten, what tests were rewritten, etc., that made
Sure.
it in the next merge cycle. I think that's the hard one to measure. And but what is very surprising to me is that what I thought was a very hard problem, I see some of the great AI companies now solving it autonomously, right? Like
Okay.
you hear about uh, Anthropic and how they do automated bug fixing and
Hmm.
kind of automated code rewriting with the fixes merged and without a human in the
Hmm.
loop and so on. So what seems hard, I think if you are able to put, but just to be very clear, I think the foundation model companies are also very good at uh,
Yeah.
realizing what context to put together to make the models
Hmm.
work. So I think they've created systems that make it easy to put that context. That is the important part of context engineering altogether. And I think uh, the other companies or all the other enterprises have to catch up to that. And
Sure.
Symphony AI being an AI company, we realize how all this works because our
Hmm.
products are AI products and use LLMs, and we know how context works. But kind of taking a step back and saying, you know, it's actually playing out in our day-to-day jobs as we are sitting
Yeah.
in front of our IDEs and in front of our deployment scripts and all that. It's often easy to lose track of that, and I think that revolution is here, and I'm just looking forward to how it plays out.
Sure. Sure. Yeah. Appreciate that. You actually bring up an interesting point as you know, engineering organizations encounter projects of all different kinds. As you're thinking about different stages in that engineering life cycle, there's those feedback loops, right? And you want to make improvements at different parts of that. Whether it's developer velocity or mean time to resolution. Is how do you think of, or what's kind of a strong mental model for you as far as like, okay, the feedback cycle is this. How much longer do I need to gather feedback before I act on it? So it's like making that like, okay, do I iterate really quickly and then try it again if it didn't work? Or do I hold out for a little bit longer, gather more data, and then iterate?
Yeah, that's a really good question. I don't think we have a good answer right now on it, and it depends in case by case. I
Mhm.
think what if you think about humans are really good at sometimes with one piece of feedback, they realize, oh, it's a fundamental problem and I got to
Yep.
improve it. Whereas in other cases, they would look at, yeah, I've seen this before, let it play out in life, and when,
Sure.
uh, I've often seen it in the case of a memory leak, for example, like,
Mm.
that if you put some kind of a report or some kind of a statistic in front of the engineer who worked on it, they would instantly say, oh, that's a memory leak. I got to debug it, and so on.
Yeah.
Whereas in other cases, they'd say, it's intermittent, maybe, restart the pods or something and it goes away and let it play out
Mm.
more. So I think humans over time have become very good at it. Uh, uh, and I think LLMs, out of kind of memorizing the data on the internet of examples
Mhm.
like these, try to be like that. But I think
Sure.
truly learning systems have to play out. And I don't have a good
Mhm.
answer for it. Uh, I mean, we try using LLMs in all parts of our development life cycle. And honestly,
Sure.
sometimes I'm surprised if when an LLM says, "Oh, that's most likely caused by a memory leak," but
Yeah.
I think it is saying there is no causality behind it right now. Like it doesn't
Mhm.
say this is because I saw this piece of code and this is the part where this is possible. It's just out of how the error looks like, and because
Sure.
it's how these models are trained that it gives that indication. But even then, just from a candidate generation perspective, if an LLM can give you four plausible causes, it's better for an average engineer to, be informed of those four, etc. So yeah, I think that's how it
Sure.
plays out. Yeah, I don't have
Interesting.
any better. I think the area is developing. We'll see how it goes. A truly self-learning system will be able to go all the way from the incident or the error to the code that resulted in, to debugging that
Sure.
code, and really going to the causality of it. I don't think we are anywhere near that.
Sure. Where do you, I guess, when you're thinking about ways to incorporate AI agentic functionality into the software development lifecycle, where do you see like the most impact? Is it on the front end with code assistance, or is it, immediately remediating incidents as they occur, or catching up on signals and remediating something before there's an incident?
I think right now, for sure, the product market fit is on the IDE side, right? Like
Sure.
Cursor, or we use Code or Client internally a lot at Symphony AI. We are really
Mhm.
big fans of agentic capabilities in Code. Uh, I mean, the one or two areas where agents have got product market fit, coding agents is one of them. And coding agents,
Mhm.
especially inside IDEs, whether it is a plugin to VS Code or whether it's a VS Code fork like Cursor, clearly we see, I think that's where we see the most impact. CLI
Sure.
based tools like Claude Code are the next iteration of it, and I think they're really powerful. But really going from like kind of suggesting the next few lines of code to really going and uh, understanding it and editing relatively large code bases.
Mhm.
And I would say more specifically, helping extend an engineer's expertise, right? Someone who was a backend engineer, for them to be able to build a front end, or someone who was a front end engineer to be able to build some of the backend or API stack,
Mhm.
and not have to rely on someone else. I think that's been the key unlock, and that's been
Sure.
I think that's been the greatest productivity increase that I see. Like everyone
Sure.
stretching their boundary a little bit to what they
Mhm.
thought was their narrow expertise, and everyone sort of becoming a full stack engineer, or everyone has the
Sure.
ability now to become a full stack engineer. And some people are really utilizing that, while
Hmm.
others yeah, are not. And I think the ones who are utilizing will win in this race.
Interesting. Yeah, that's helpful to understand from your perspective. There was something in my research that I was kind of curious about, and there's like a transitional point as you moved from Microsoft in, being more consumer AI oriented
Yeah.
to Symphony AI, where it's enterprise grade AI. Was there a realization or something that happened, an event or something where you said, okay, we need to approach enterprise AI differently? Like the way we were doing consumer AI, it needs to be different. Like it's not going to cut it in the enterprise world.
Yeah, so to be fair, my transition point happened inside Microsoft itself. And
Mhm.
I transitioned, I did search relevance and kind of relevance and ranking machine learning algorithms and platforms for search and ads for a long time, which is very much like a Google search like business, which is very consumer
Yeah.
oriented. The transition point was we started using or adopting the same algorithms to do uh, more predictions in the beyond search, right? So, for example,
Sure.
we started saying, can you use search data to predict a demand of a new product?
Mhm.
uh, right? Because people search for things, and you have like
Yeah.
search trends. You can imagine Google Trends being used to predict a new product forecasting or demand for a new product.
Sure.
Uh, or you could use search and social data to predict how the economy is doing, how many jobs are getting created, etc. And we
Mhm.
immediately realized that as soon as you come out of search data into using enterprise zone data, because say if you're predicting, and back then, like this is more than 10 years ago, we were predicting how many SUVs, what's the demand for SUVs? So if a car company
Yeah.
is going to come up with a new model next year,
Mhm.
how many should they plan on manufacturing, right? Because it's a very key
Yeah.
decision. These are very
Sure.
expensive things. You have to procure a lot of
Mhm.
parts and raw material, etc. Um, and you realize that on one side, you have search and social data, and you have complete
Mhm.
control over it. And it's been relatively cleaned and available for machine learning, like it's AI ready. And on the other
Sure.
side, you have enterprise data, which is very not clean, which is
Mhm.
not in the same time horizon as your other data.
Yeah.
So, I think that's whenever you start bringing in an enterprise's own data sources, you realize all sorts of problems. You realize availability of
Sure.
them, you realize how disparate they are in terms of their dimensionality, in terms of their time horizon for which they are available. And all your
Mhm.
algorithms were based on this kind of I have access to 5 years worth of data. Well, you have access to only 6 months of one data source, and like,
Sure.
three or another data source. And much of that is not clean and usable.
Mhm.
And so all your machine learning frameworks kind of start failing in that respect. Add
Sure.
that to an aspect of what modern foundation models would say. They are pre-trained on very large data,
Mhm.
which is also gathered and made available and pre-cooked and all that. But in many
Yeah.
cases, in enterprises, there is a small data, but very particular nuance just for this problem, just for this product data.
Sure.
So it's not like you can extend the idea of these large foundation models that'll work. Um,
Mhm.
I think as you get into trying to solve predictions or any sort of recommendations in the enterprise, and you go for a machine learning or an AI person, the first thing they go into is data. As soon as they go into data, that's
Mhm.
when they realize enterprise is different, enterprise is hard.
Yeah.
I'm not even talking about other aspects around privacy and security and so on, right? So you
Sure.
should not be using many of the data sources in there, or your data
Yeah.
will overfit to something that is very personal or something
Mhm.
like that. And so I think I was always a machine learning practitioner, and for me, the difference was very clear. But at the same time, the opportunity for impact is also very clear, right? Like for
Yeah.
all these reasons, AI found it hard to penetrate enterprises, but the value AI can bring in the enterprises still exists. And so to find ways around it, and like eventually people found ways around it. Like we used to we used to fine tune models even 10 years ago, and now fine
Sure.
tuning has become a very standard way of guiding your model to do well on certain tasks for which you have
Sure.
less, etc. Uh, so I think algorithms catch up and so on, but I think enterprises remain hard from that perspective.
Yeah. In that example specifically, the thing that really resonated with me is the work you're doing in manufacturing in particular. It's like predicting when parts are going to fail. Like that data, I think of difficult data to consume and use and absorb. It's like,
That's
so
right.
are you, how do you get that data? Do you have a video camera on critical parts and you're just like, trying to figure out, okay, is it worn out enough to justify it? Are there sensors attached to it? It's like, how do you get access to that data and then transform it into something that's usable?
Right, absolutely. And so yeah, you hit on it. In certain industries we work in, just the procurement of data itself is the issue.
Mhm.
And you go from cloud to edge, and you work at kind of uh, edge data platforms or edge data collection
Mhm.
techniques, and you look at ML models that can be applied on the edge, etc.
Yeah.
So particularly in the industrial manufacturing domain now in Symphony AI, those use cases are very valid. You imagine
Mhm.
you go to a plant and there's been a boiler that was been there for 30 years, and it's got
Yeah.
this kind of pressure gauge, which is this analog
Yeah.
sensor. And so well, either you tell the company that you digitize all this, which is millions of dollar a project,
Yeah.
or you can just put a camera on a factory floor somewhere and you start collecting analog data, and you put an LLM behind it and it'll tell you what reading
Yep.
is. And so
Yeah.
with technology, the choice of solutions also rapidly changes. And so not just in
Mhm.
industrial and manufacturing, but even in our retail CPG business, we extensively used image, video, speech, like multimodal data sources, because
Mhm.
converting them into structured data has become really easy. What used to be very hard.
Sure.
Also, the hardware has become cheaper, etc. And so, yeah, we that's these are all the areas we have to keep pace with,
Sure.
and and go all the way from data procurement to now data contextualization and
Mhm.
adding knowledge and semantics to it, right? So, in industrial manufacturing, for example, our main focus is contextualization of that data, because
Yeah.
that data coming from one asset or one machine in
Mhm.
context of the data coming from other related assets of machine, and
Sure.
to call out that the whole plant is operating at this rhythm, it's a hard problem.
Mhm.
It involves many
Sure.
aspects of entity resolution, what we call unified namespace. Uh,
Mhm.
the same asset name is mentioned differently in the manual for that asset. And so if something goes wrong
Yeah.
and you look it up, you will not find that name. And so you have to make
Sure.
sure when you're ingesting the manuals or the procedure manuals or troubleshooting guides which are on paper. Sometimes you have to digitize that.
Yeah.
You will realize that, oh, there's no name like this, and
Yeah.
so you have to add some AI to also do name resolution there.
Sure.
Just I mean, you should think of it as a model zoo. Like there are so many
Mhm.
models working throughout the process. There is a vision
Yeah.
model working at the edge. There is a predictive model resolving the entities. There is a generative
Hmm.
LLM kind of doing the identification and resolution of the use cases. So the end solution that we provide is really a model zoo that goes out and
Sure.
get deployed. And that's not easy to do, but that's the that's the claim we make to enterprises of
Sure.
what we're good at. Yeah.
Yeah. Interesting. Yeah. I love the example use case you happen to pick. I grew up in Northeast Ohio. My dad was a pipe fitter, so he worked on boilers and was always in boiler rooms. So I know exactly what you're talking about as you describe that.
Yeah.
So that's interesting, and that kind of gets to another question that I had for you, which is serendipitous. It's like you've explained this to other folks in other interviews, but I'd love for you to share with our audience kind of the why you've gone industry specific and why that nuance is so powerful.
Yeah. Um, I think I lived firsthand the uh, kind of horizontal versus vertical argument or choice.
Mhm.
And I've built a lot of what you would call horizontal AI back in Microsoft. These are kind of general purpose AI models that get deployed, kind of like foundation
Mhm.
models, but this is pre-foundation models era, like sentiment analysis or
Sure.
anomaly detection or other kinds of auto ML models, etc. And
Mhm.
you would go and use them in real scenarios, and there was always a need of customization.
Yep.
That was reality, right? So if you took a general purpose sentiment analysis model and you go and try it on product reviews, you could always do a little better by tuning it on product reviews, etc. And so
Mhm.
uh, so there's two approaches now. Either you go all the way to hyper customizing it to every customer, like doing it on their own, etc., which is then
Mhm.
a services kind of a business, like or these companies hire their own individual AI
Sure.
scientists or engineers and do it. Or you say that let's go at least to a level where these problems are common across companies. And as soon as you get to that, I think that becomes a definition of a vertical, right? So you would
Sure.
see in other AI industries, like people call, like there's legal AI companies now, right? And so
Mhm.
in lawyers and legal space, there are certain problems that are very specific, and every
Yep.
law company would have it, and that's the definition of a legal vertical. Similarly,
Mhm.
we are in retail CPG, we are in financial services, especially financial crime, and we are in industrial manufacturing. Now, other than the size of these markets, which is attractive to us, and
Mhm.
the opportunity to bring AI and automation through AI that exist in these industries, really what is common across these is that the problems are very well understood. The processes are very
Sure.
well understood. Like you're not inventing a problem, right? They've
Sure.
existed. You just
Mhm.
have to go and model it. Sometimes the modeling of it is as a predictive AI problem. For example, in the
Sure.
financial crime space, you have to detect crime, right? So either a
Mhm.
transaction or its associated transactions are fraudulent or they are not. It's a
Yeah.
detection problem, right? And it's like a predictive problem.
Mhm.
And then you have to investigate it. Investigation is like this research project, right? So
Yeah.
a modern analogy would be a deep research agent would be very good at that kind of a task. And then finally, you have
Sure.
to report it with the regulatory authorities. And so
Mhm.
having all the information about a case and then filling a PDF form as a report to file it is again a very well understood machine learning problem. So, uh,
Sure.
and this is common across banks, across financial institutions. Now,
Mhm.
the nature of fraud changes and the algorithms have to adopt to catch it. The nature of investigation could be a little custom in one bank versus another, but these processes are very common. So
Sure.
when you build models and you build AI agents or agentic workflows that solve for these, they have applicability across all these companies that operate in this space. So that is whereas if you take a general purpose AI agent and apply them on it, it will not do very
Mhm.
well and always almost
Sure.
always need some customization. So this definition of vertical is, in my mind, the right balance on like right middle ground on which to operate. Not super
Sure.
custom, not every company doing their own, and not as general. Now we'll
Yeah.
see how this area grows. Like I think the foundation models
Mhm.
are very good. They might get very good at a lot of problems. It's something
Sure.
we keen eye on. But
Mhm.
so far, this definition of vertical has been really good and has been really easy to apply AI at uh, and see the returns of applying it.
Sure. Sure. So that I love that, and that leads me to a follow-on question for you. As AI co-pilots become more commonplace, they get better at doing the things that they do well, and you incorporate them into your SDLC, and you're seeing all the benefits. How do you think of that? Do I develop something net new for a new industry or a new vertical, or do I repurpose something that gets me part of the way there? But I'm kind of curious. Like, is it easier to rebuild something that's partially good at what you need it to do, or to kind of start from scratch? Because it's so much easier to get things going now with the co-pilots.
Yeah, I think even when you start from scratch, it's never really scratch these days.
Sure.
So like when you even start with a model, you always start with a foundation model, and then you always start with, and this is whether it's an LLM or it's some other predictive model, you always start with a pre-trained model. A pre-trained
Okay.
model has already does well in enough domains, and you
Mhm.
start there. And then you repurpose it or fine tune it to those particular domains or tasks. And that works for a wide variety of almost 80-20 rule. 80% of the problems you could start with a
Sure.
pre-trained model and then you fine tune on it. The key is your fine tuning algorithm and data should be very good, right? And so
Mhm.
that's what we rely on. We would say, and an extension of that is that your definition of that new verticals process or how you define workflows and processes around it should be very well understood. So
Sure.
you can start with as a example, you can start with a deep research agent like OpenAI
Mhm.
or Google also have deep research agents, but
Yeah.
you have to plug in the right workflows which are vertical specific, and you have to assign the right
Mhm.
tools which are
Sure.
and then you have to make sure this agent utilizes all that and not just
Mhm.
search as a tool and not just code writing as a tool.
Sure.
And but almost always you start with something not scratch. And
Sure.
so I think the world has already reached that. The second thing I would say is platforms play a big role in it. So whenever
Mhm.
you start with a platform, and we have a very good platform we call Eureka AI platform internally for internal product building, uh, the platform approach really brings in a lot of things that are already there. You have workflow
Mhm.
managers already. You have uh, uh, kind of if you think of like model builders, you have model building pipelines and model inferencing pipelines already, and so
Mhm.
on. You think of life cycle of a case in case of a fraud. Well, the life cycle
Sure.
of an incident in IT services is very similar.
Mhm.
So over time, we've built these platform capabilities that allow us to scale very easily to a new vertical. But then in that vertical, you need to specialize.
Sure, sure. That's interesting. What I'd be curious to understand, you know, what is it that you think is a good indicator to branch into a new market? You had mentioned legal. It sounds like there's a lot there, given the number of law firms that exist across the country, right? There's that's a big space.
Yeah.
Um, how do you think of that? Like the opportunity versus the time it would take to get a product that's good enough to, go to market with.
Uh, I mean, internally, we have at SymphonyAI, we have a framework we call the Product Innovation Framework. And
Mhm.
so we ask a lot of questions around why this vertical, why now, why us? And we have a
Sure.
framework around good answers for it and bad answers for it. And so some
Mhm.
of the things are, quite obvious to understand that uh, uh, if, for example, why now is a very clear example, like some new technological advancements are there now that makes this problem much more feasible than it was before, then that's a good area to go at. A good
Sure.
example is uh, browser agents or computer use agents. So many things we
Mhm.
do were not possible unless your agents could see, as human eyes see things and
Yeah.
operate on browsers and all that. So sometimes technological advancements make it possible to do things. Uh,
Mhm.
uh, why us is always a good question as well. Like how many other players are there? What distinct advantages do we have? Is it
Yeah.
similar to the vertical we operate in? Is it easy to get into? Do we have the platform capabilities, etc.? Is it vertical enough? That's often an
Mhm.
important question these days, right? So, if, for example, the processes or the models required in that vertical are not very vertical. If any
Sure.
horizontal models would do a good job at that, it's probably not a good one to be in. I mean, it's good for a hyperscaler or a Databricks or someone to be in that space, but
Sure.
I think we'd like to differentiate in verticals and keep that vertical focus.
Gotcha. That's great. Thank you. I would like to pivot a little bit and kind of get into, more of the software development lifecycle writ large, right? So as you're thinking about, we went from waterfall to agile to DevOps and DevSecOps, and now there's a whole bunch of autonomous functionality coming out. Um, but there's something in particular, like DevOps did not do a great job of solving infrastructure automation. So I'm curious kind of what you think this new functionality that we're seeing with agents, kind of bringing to the table that DevOps just struggled to really wrap their head around.
Yeah, I think it's a great question and very pertinent to StackGen as well, and
Mhm.
what StackGen is trying to do. Man, really, I go to the first principles on agents and what defines AI agents. I mean, there's so many different definitions, and the word is very confusing now. But I
Yep.
think for me, there is two or three main properties that an agent has. I think the first is what I call perception,
Mhm.
meaning an agent is there has to be some kind of monitoring capability where it is looking at its environment, or when
Sure.
provided signals to its environment, it is figuring something out. So meaning it is
Mhm.
proactive and not reactive.
Yeah.
Second is once given its environment, it should be able to reason around it. And that goes
Mhm.
into reasoning capabilities that the models added. So you could have had very proactive kind of monitoring or observable agents before, but when a new
Mhm.
observation comes in, what do I do with it? They would just go ask the human,
Sure.
right? And
Yeah.
so now they are able to reason on its own, especially if you give it enough context with past instances of these things having occurred or its own knowledge
Mhm.
from its training data of what to do. So second is reasoning, and the third is tool use, which is also you can call
Sure.
actionability. So
Mhm.
once it reasons and once it plans, can it execute on it? Can it do something about it,
Sure.
right? So
Yeah.
uh, for me, these three pillars are very important. And if you think of
Mhm.
so perception, reasoning, action, you can other people call it a little different, but if you just look at that as a framework, and you now put DevOps or DevSecOps in it, uh, you know, perception is about like active monitoring, right? So there's
Mhm.
different kind of things that fail in production. Like one is
Sure.
some functionality failing, which is the result is a bug. Second
Mhm.
is some machine or compute or some environment failure, and that's another kind of incident that happens.
Sure.
And uh, and then if you think of reasoning, the reasoning across both of these is different. Reasoning across infrastructure failures is around uh, what was provisioned, what went wrong, observing whether it was memory or storage or network, like which of these three
Yeah.
caused it, etc. The resolution of a bug is okay, what's wrong in the code, and having access to code bases and so on. And then action is again different. An action in infra is restart the pods or escalate at someone.
Yeah.
An action in the case of a bug or code is to perhaps rewrite
Mhm.
or fix the bug autonomously, do the autonomous merge and so on. So now, if you think of in terms of these angles, you could never achieve the level of autonomy you do with LLMs these days in these three
Sure.
areas, across perception, across reasoning, and across actions. Uh,
Mhm.
and and I would say that especially in the action world, the emergence of standard protocols like MCPs and so on is also making things more standard, right? So you
Sure.
don't have to worry about custom integrations with everyone like Jira would have created its MCP,
Mhm.
or you'd have database MCPs and all that as well. So I think that's kind of for me those three pillars, and how because of the how good the foundation models and LLMs have become, and how good the ecosystem around them, especially around protocols like MCP, has forced that ecosystem to for the kind of owners of systems of records and all to build these MCP servers.
Mhm.
That whole thing coming together, the time is ripe for innovation in this area.
Sure. Yeah. That's great to understand. I appreciate that. I'm
Yeah.
That kind of sends me in a different direction though, but still we're going a little bit high level up. When it comes to an engineering organization that is people, tools, culture, communication, collaboration, um, how do you think of it as a CTO? You've grown organizations, you've been part of large organizations. DevOps is a methodology. It's not a tool, right? If you implement GitLab or GitHub, you're not DevOps, right? It's supportive of that methodology. But I guess, how do you think of like helping an engineering organization mature, and what are the things that you're looking at, across tools, org structure and people and culture?
Yeah. I think what we just discussed before this, the arrival of agents and LLMs or tools that can automate a lot of these things has
Mm.
somehow has resulted in really Like I asked myself this question that you asked, and
Hmm.
the answer is very different from what it would be in a few, 2 years ago or so.
Sure. Hmm.
And so I almost re-ask myself this question every few months and see the role
Hmm.
change because the maturity of this tool set and others that have. So, for example,
Yeah.
uh, a few years ago, probably I think everyone in the industry noticed that uh, we used to have the traditional devs and QA and other teams, and then suddenly devs were doing most of the QA themselves, right?
Yeah.
And it's just and so if you look at that curve mature, now you see devs should be able to do deployments themselves. And wherever
Hmm.
devs get stuck, there should be like this uh, uh, supervisor who helps out, and that could
Hmm.
either be a human or that itself could be an agent in many
Sure.
of the cases. So the role of um, I think the role of DevOps, uh, like I personally don't like these silos where one person does something and just hands it over across the boundary as if it's someone else's job to do the rest.
Sure.
And I've never liked it even before as a data scientists used to write uh, models and training code in notebooks and just hand it
Hmm.
over devs to
Yeah.
productionize it. And then devs would take it out of the notebook and like remove all the
Yeah.
whatever Jupyter code around it, and then I think the tool set evolve. I think the same idea applies now, and I think uh, I really see the role of engineering teams to take accountability and ownership more and more of the dev life cycle, all the way from writing code to
Hmm.
deploying code and monitoring and resolving it. And even that changes a lot, right? So, like if you look at the role of a developer, I think a common uh, you know like kind of belief now is devs have, like with AI writing a lot of code, devs have to evolve into manager of agents or supervisor of agents,
Sure.
etc. And I think while I'm not fully in that boat, but I do think
Hmm.
we have to get used to a world of even before devs, there's AI that writes code.
Sure.
And the devs have a role of kind of figuring out what's wrong, supervising it. Uh, then AI is doing code reviews, but the devs have to play a
Hmm.
role of, wherever something is flagged, you should go and look at it. So I think the
Yeah.
roles are changing very fast. And I think I'm a big fan of the devs evolving their definition of what is in their control and really
Hmm.
accepting that a lot more can be in control and kind of accepting that and encouraging that. Now, the
Sure.
role of DevOps doesn't go away because of this. Like just like the role of QA went from actually doing manual QA to building automation frameworks, I think the
Yeah.
role of ops goes from there should be agent builders, right? Like
Hmm.
there should be ops agent builders going forward that
Sure.
train and improve autonomous infra systems,
Yeah.
uh, and make sure the devs get alerted and they are able to resolve
Hmm.
and things like that. And so I think uh, in some sense, the DevOps themselves become like supervisors of AI in their realm.
Sure. Yeah.
But I think the short term, uh, if we all see our roles as agent builders in
Hmm.
in each in each dimension we are operating in, I think we'll learn a lot and we'll be ready for the future ahead of us. That's my message to my entire team in Symphony AI.
Sure.
Some people get it fast, others will take time. Yeah.
Yeah. Yeah. I've seen it over my career, which it spans 15 years at this point, selling software development software. And every single iteration of a new methodology, we're asking developers to do more and more, which means they have to learn a new set of tools, they have to learn a new set of skills, and that cognitive load just piles on and piles on and piles on. And I think you're spot on. The agentic aspect of technology today does seem like a way to enable that developer to do a lot more
Yeah.
without having that additional cognitive load.
Yeah, yeah, I 100% agree. I think because English becomes a simple language of translation
Mhm.
without you having to, if the agent is good at kind of translating that into,
Yes.
yeah, yeah.
And so I've got one final question here,
Mhm.
and it's, if you were to give a piece of advice to leaders who want to build AI solutions, right, that get through the hype, right, because it's difficult to get through there, and it's very easy to have something very surfacey that doesn't go deep enough that you're solving real problems. So what would a piece of advice be to somebody who is trying to tackle that and build something in the AI space?
Uh, I mean, I get that question a lot, and I mean, from our customers as well. I think everyone gets sort of some pressure of, oh, you have to do AI and so on. And what do I, where
Yeah.
do I start? What do I do? I think the first thing I always say is you should be clear on the problem. You should not
Hmm.
throw a solution at something and then go figure out problems based on them. That's the first mistake
Sure.
that people do, uh, whether it's in the products we build and we sell, and which is why we like the vertical AI space because the problems are very clear. It's not like we
Hmm.
build, a lot of cases, if you see OpenAI, Anthropic, they have a solution and they would go looking
Yeah.
around problems for that now. I mean, the great thing
Yeah.
is that the applicability of these is so much, but a lot of startups have this problem. They just,
Hmm.
try to throw the solution at it. Uh, the second thing I would say is related to the first thing is once you've understood the problem, spend time building a benchmark or an evaluation set for it. In the AI
Sure.
world, it's called evals. It
Hmm.
will take time. It seems boring. It seems, who cares for it? But the more you do it, the better, more data driven you go. Otherwise, you're going blind. And this
Sure.
applies even in the SDLC world. We should build some evals. And there is so many
Hmm.
examples of benchmarks and evals out there now on which LLMs are, benchmarks against that you don't have to start from scratch. Right?
Sure.
Meaning there should be some definition of success, some definition of failure. It could be
Hmm.
fuzzy, cannot be very precise, but it should result in a number. And then, typically you'd be able to test how you're doing today on that number, right? So maybe
Sure.
with manuals, maybe with humans, maybe with rules that you are there right now,
Hmm.
you should be able to. And it's hard. It needs effort, but it's worth it. If you are serious about it, you should have evals and benchmarks. And maybe the third thing I would say is when you're implementing AI in production, you know, don't forget about durability of that AI, right? So if you're doing
Hmm.
agents, the durability of agents, agentic systems, meaning figure out all possible cases where they will fail, and they can fail
Sure.
many places. The tool call will
Hmm.
fail, the LLM call will fail, the actions will fail, your infra will fail, etc.
Sure.
And there are different parts of your stack which will be made which will have to be made more durable. And
Sure.
that's the biggest lesson in going from prototype to production. Two things
Okay.
really, reliability and durability. And so if you don't do, you can do a reliability test with evals, For
Mhm.
example, you would run an agent twice and it does something, and you would think if I run it 100 times, it'll do the same thing. And that's not
Yep.
true. It realized it will probably do it 94 times, and 6 times it'll do something else. So
Sure.
an eval will show it.
Hmm.
Uh, and then second, uh, when it doesn't do it, maybe something failed, and then having a handle on how do you recover from that failure. And ideally, your system should recover on their own,
Sure.
versus human has to be involved to do that recovery. It could be a retry logic on an API. It could be rate limits on your LLMs. It could be n number of things throughout that workflow stack that might fail. So I think those are some practical lessons from applying AI and taking it to production that I keep in mind.
Awesome. Awesome. Raj, I do appreciate all the time you've spent with us. I know there's going to be a lot of folks that are interested to hear your thoughts on a number of these topics. So definitely appreciate your time today.
Thank you. Take care.
Awesome. Infrastructure Unbound. This is Rick. As we wrap, remember, build platforms, not bottlenecks, unless chaos is your kink. Bye.